Hello, dear aspirants. This is Dr. Saurabh Sir's classes. We are Dr. Saurabh Sir's classes team, and we can see that this is our contact number, which is 98367 93076. Again, I am telling the number, which is 98367 93076. Please feel free to call on this number to if you have any doubt on mathematics or etc or any subject doubt. Please call on this number and our team will help you out from the uh, from the doubtful mindset. Okay, so if sorry, now we are solving some TIFR GS question. So this question is telling us that consider the following statement: any linear map which is from R cube to R cube has one dimensional invariant subspace, and any linear map R cube to R cube has a two-dimensional invariant subspace. So now what is an invariant subspace? So if our W be a subspace of R cube, it will be called invariant under map T if our T of small w will belong to W and for all W belongs to W. That means in other words we can easily say that any vector from this map, that is what? Okay, so in simpler terms, W is invariant if applying T to any vector in W keeps the resulting vector within W. Now, a one-dimensional invariant subspace corresponds to a line. We can easily say that corresponds to a line through the origin that remains invariant under T. Such a subspace exists if T has an eigenvector. Okay. So now a two-dimensional invariant subspace corresponds to a plane through the origin that remains invariant under T. Such a subspace exists if there is a complementary one-dimensional invariant subspace or T has a direct sum decomposition. Okay. So now we are going to analyze the statement 1, that does every linear map T is going from R cube to R cube have any one dimensional invariant subspace? Okay. So a one dimensional invariant subspace exists if T has at least one eigenvector. This is equivalent to T having at least one real eigenvalue, as the eigenvector corresponds to the line spanned by that eigenvector. Okay, now for 3 cross 3 matrices, what will happen? We can see that the 3 cross 3 matrices, the characteristic polynomial is a cubic polynomial. And okay, I don't want to write this thing. Yeah, a cubic polynomial, then with real coefficient as so it has at least one real root. So this implies that is always has at least one real eigenvalue and thus at least one eigenvector. So the subspace spanned by the eigenvector is a one-dimensional invariant subspace. So our statement 1 is a correct statement of this question. So okay, so now we are going to think about our statement 2, which is this, that does any linear map T from R cube to R cube has a two-dimensional invariant subspace or not? So okay, so what is invariant subspace? We know that. So our eigenvalue and eigenvector. Okay, if T has a real eigenvalue, then corresponding eigenspace forms a one-dimensional invariant subspace. So we can easily see that. Now after that, In R cube, this implies the existence of a two-dimensional invariant subspace as its orthogonal complement, which is invariant under T, and the characteristic polynomial and the complex eigenvalues. If T has no real eigenvalues, then what will happen? In such cases, then the characteristic polynomial has complex conjugate eigenvalues. We can see that in such cases there is still an invariant subspace of dimension 2 corresponding to the plane spanned by the real and imaginary parts of the eigenvector. So in all cases T has at least one two-dimensional invariant subspace. So this statement is also true. So the correct option of this question will be 1 and 2 both are true, which is my option A. So again I am telling that please feel free to contact on this number, which is 98367 93076. Then we can help you by solving your doubts or by one-on-one classes and by the batches. Okay. Thank you guys.